What you're looking at is not some cruel fraternity initiation game. These lumps are being taken in the name of science. German roboticists at DLR Robotics are looking at new ways to develop safe robots able to work side by side with humans. And their creations so far are nothing short of spectacular. The roboticist behind all of the punishment, Sami Haddadin, joins me today to tell me about his new breed of safe robots. Hi, Sami. Wie geht es Ihnen weiter? I'm attempting my German here.
Yeah, it sounded almost perfect.
As we can see here, you put yourself forward as the guinea pig to test the arm. Can you tell me a little bit about the testing?
Well, the point is, here at the German Aerospace Center, DLR, we develop a new generation of safe robots, especially, let's say, developed for the physical interaction with human beings. And in order to kind of estimate the safety level that we can gain with such a robot, we conducted impact experiments at the German Automobile Club ADAC. When I did the experiments with myself with a lightweight robot, I first did it with the collision detection and reaction, so the robot was able to detect that it hit me and react in a compliant manner. But as well, I did these experiments with switching that off. So I really wanted to know, what is the worst case that could happen with this robot? And apparently, since I'm still alive, it was no problem. The robot is intrinsically safe. Based on these experiments with our robot that we developed here, we compared it with other industrial robots ranging up to masses of 2.5 tons.
So at any point, were you concerned about your own safety?
Well, I would say in the beginning I was a little concerned, but not because I did not know what would happen. It was just that nobody has done that before. So I really was not sure how it feels. I knew that the robot must be safe due to the experiments we conducted at the German Automobile Club at these crash test facilities. So it took me maybe a few minutes in order to really get to know what is happening. But from then on, it was actually very not comfortable, but it really felt safe, I would say so.
Did you happen to gain any interesting results?
Yeah, definitely. I would say that one of the most important results out of this study, not only with the lightweight robot, but with the industrial robot as well, is that if you're in free space, then actually no robot, whatever mass it has, could really injure yourself. Industrial robots can especially be dangerous in confined workspaces or in confined spaces in general, since they can trap you and then crush you. This is not the case with a lightweight robot. So if you have a very light robot, then this is definitely a very crucial safety feature, to be light at the same time, being able to carry high loads.
So how do you build safer robotic arms?
Well, I would say it's a complex mechatronic design. So what we do is we integrate the electronics, the motors, everything in the robot, and we equip it with joint torque sensing, meaning that the robot can sense external disturbances or forces along the entire structure. So not like with classical industrial robots that you can only feel at the tool center, so where the tool is actually mounted, but you can really feel along the entire structure, for example on the elbow. So the robot hits a certain object like a human, but at the same time it can detect the collision and react in a compliant manner. This means the robot switches within very quick time to a compliant mode and can be simply pushed away. And you have the feeling that it weighs only a few grams.
How will this robotic arm be used industrially?
You've got a robot that has the possibility of interaction, of physical interaction, meaning that a human worker could collaborate with such a robot, and the robot could provide him with assistance. So you do not have this classical positioning machine like industrial robots, which have to be put away in cages, but you have human and robot sharing the same workspace, so really physically cooperating. And by that, you can utilize the capabilities of the robot in order to do certain assembly tasks. For example, what we have here in our lab is a puzzling demonstration where the lightweight robot is actually assembling a puzzle and can only do this due to its compliance, due to its reactive movements. Furthermore, I would say it is not only applicable to industrial applications, but as well to domestic ones. For example, here at the lab, we've got a ball catching application where we have a computer vision that actually estimates a human throw over the trajectory, and the robot can anticipate and react to that, predict the motion of the ball and catch the ball with the robotic arm and the hand.
You know what? That robotic ball catcher, it's pretty amazing. Do you have any future plans?
New projects that are right now in working phase are, for example, transferring the safety concepts that we implemented and developed for the lightweight robot to transfer them to our DLR humanoid Justin, which is standing behind me. Justin is already able to fulfill various tasks. For example, he's able to prepare and serve tea. Also, Justin is able to manipulate various or very complex objects. For example, tea bins, or he can hold 3 soccer balls at the same time. Furthermore, Justin is actually planned as a robonaut, so it's supposed to be a co-worker in space. So if an astronaut is doing certain tasks in space, it's supposed to help and support the astronaut. Another project that is right now going on, or where the hardware was just set up, is the crawler, the DLR crawler. It's supposed to explore Mars and is basically designed on the same principle as the DLR hand. So the robot is very robust to unknown environments. The robotic crawler would not get stuck in unknown terrain, as for example on Mars, since it can adapt.
Well, that footage of your robot pouring tea is so remarkable, such precision. You almost want to develop emotions for that machine, which is pretty amazing. Thank you so much for joining us, Sami.
I thank you very much.
Sami Haddadin is a roboticist at the DLR Institute of Robotics and Mechatronics, and he joined me